good day to do some math, do some probabilities. Hopefully Nate made it here because he seems to get lost a lot. If you're here, Nate, give a shout out. Notes. Okay. So let's do this. So what we're going to be looking at is the AND and OR probabilities. Okay. We're going to see what the difference is and how to set those ones up. Okay. So let's start with the first question. So hopefully you watched the videos last night and you were able to understand. It was kind of straightforward when you're using which, but you know, some of it might have been a little confusing, so hopefully we'll be able to fix that right now. So here's exercise 6 and 7 that was not on the video last night, so we'll go over them now. So exercise 6 says the probability it will rain tomorrow is 1/2, and the probability that our team will win tomorrow's basketball game is 3/5. Which expression represents the probability that it will rain and that our team will not win the game? Okay. So if we look at what they gave us in the problem, they said the probability that it was going to rain was 1/2, and then that the probability that you were going to win was going to be 3/5. The question says that it's going to rain and that our team will not win the game. So the probability, here's the question, that it'll rain and it's going to not win. Okay, rain and not win. Remember, when you're doing and, you want to multiply. So the probability that it's going to rain times the probability that you're going to not win. Probability that you're going to rain is 1/2. And now to win, you had 3/5. So the probability of not winning would be 2/5. And again, that comes from if you're going to win 3 out of 5 times, then you're not going to win 2 out of those 5 times. So you're just basically subtracting 5 minus 3. And then that's going to be 2/5. So it's 1/2 times 2/5. And there it is, number 4. Okay. Exercise number 7. Okay. Nate, you made it. Did you get lost? Okay, so Alex and Jen have volunteered to serve on the senior prom committee. The names of 20 volunteers, including Alex and Jen, are put into a bowl. If 2 names are randomly drawn from the bowl without replacement, that's pretty important. What is the probability that Alex's name will be drawn first? Jen's name will be drawn second. Okay, and here's that AND again. So the probability that first we're going to get Alex, okay, and then after that we're going to get Jen. So I want to know what's the probability that I get Alex times the probability that then I get Jen. So Alex, there's 1 of him, and then how many total volunteers were there? And it says that there were 20, so it's going to be 1 out of 20. Now, how many Jens are there? There's 1 person, Jen. Now, how many volunteers are left? It's not going to be Alex again because it's without replacement, which means once Alex comes out, he's not in there anymore. So it's 1/20 and then 1/19. And again, we're going to multiply. So it wouldn't be choice 1 because this would be replacing Alex. This doesn't make any sense. And then this here, remember, you're not, or is usually when you're going to add. So that's why we're not going to be using addition. All right, so now let's run over to the homework questions, and we'll go through these ones here. Okay. Oh, there are my answers. So a fair coin is flipped 4 times. Find the probability it will land heads up each time. So you're going to be flipping it 4 times. So probability of heads. Then you want to get it again. Then you want to get it again. And then you want to get it a 4th time. So what's the probability that you get a heads on the first? 1 out of 2. Probability, again, you get a heads, and a heads. So there is a 1 in 8 chance, no, 16 chance that you are going to get heads 4 times in a row. Okay, now this one's a little bit different. Find the probability it will land the same way each time. Well, think about it. If you're going to land the same way each time, so again, it's happening 4 times, a coin only has a heads and a tails. So you can either get 4 heads or you can get 4 tails. Okay, this is where this comes in now. So first, what's the probability that you get heads 4 times? Well, we just did that one right there. 1 out of 16. Now, what's the probability that you got 4 tails? Okay, tails 4 times. Well, is the probability any different? No, because it's still 1 out of 2, except this would be tails, 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 tails. So it's going to be the same thing, 1 out of 16. Now, again, use your calculator, or maybe you're good at math, who knows? That's going to be 2 out of 16, and then your final answer is 1 out of 8. Okay, so there's B. Okay, let's go to number 2 now. Okay. A first grade class of 9 girls and 7 boys walks into class in alphabetical order by last name. What is the probability 3 girls are the first to enter the room? Okay, so if we look at it, we have 9 girls and 7 boys. So that means I have a total of 16 students. So what I want, okay, well, what's the first one that's going to walk in? We want 3 girls, so the first one's going to be a girl. So how many girls are there? 9. How many students are there? 16. Now, after that, I would want another girl to walk in. So if there were 9, now there's only 8. And one of them already walked in, so now there's only 15 students that could be left to walk in the room. And then again, go down by 1, you want another girl. So then there's only 7 more girls left, and there are only 14 more students. So each time you're dropping by 1 because the girls are walking into the room. Now you're going to go ahead, you're going to multiply the 9 times 8 times 7, and that's 504. And then you're going to go ahead and divide, that's 30,360, or 0.15. Okay. Take your time. Don't try to throw this whole thing in your calculator. Easier, multiply all your tops, multiply all of your bottoms, and then divide for your answer. Okay. 3. A bag of marbles has 12 red, 8 blue, 5 green. If 3 marbles are pulled, find out each of the probabilities. In each question, they're going to specify either replacement or with no replacement. Okay, so remember, if you're going to replace, it means you're going to be putting it back, which means that your total is not going to change throughout. And if it's without replacement, that means you're keeping it. And depending if you're choosing 1, your total is going to drop by 1. Okay, so question 1. Find the probability of pulling 3 green marbles with replacement. Okay. How many green marbles are there? Well, there are 5. And then there are a total of 12 plus 8 plus 5. So you have a total of 25 marbles. So we're going to be pulling out 3. 1, 2, 3. I want the first one to be green, the second one to be green, and the third one to be green. There are 5 out of 25. Now, again, you're going to pull the green marble out, and it says with replacement, that means you're going to drop the green marble back in. So once you do that, in the second pull, there's still going to be 5, and there's still going to be 25. Same thing, still going to be 5, still going to be 25, because each time you're going to replace the marble back in there. So then this is going to be 125, and then this is going to be 15,625. Again, you can simplify with your calculator, 1 over 125. Okay, B. Find the probability of getting 3 red marbles without replacement. So it's very similar. We're going to be pulling out 3 marbles. I want all of them to be red. So on the first pull, okay, look over here, there are 12 red marbles, and there are a total of 25. Now, there are 25 marbles. I pulled one of them out. Pretend it's red, okay, I put that off to the side because it said without replacement. That means when I go to pull another one out, there's only 11 left, okay, so there's only going to be 11 left, and now since I took one out, it's going to be 24. Then over here, now there's only going to be 10 left, and then that's going to be 23. Multiply across, that's 1,320 over 13,800, and that ends up being 11 over 115. Okay, so there you go for point B. And now, if you really quick want to look at the difference between the denominator in A and the denominator in B. So the denominator in A was 15,625, where the denominator in B was 13,800. So by putting the marble back, there's a larger denominator, which makes it, there are more possibilities, which means it makes it more difficult. Okay, so now, find the probability of pulling 3 marbles of the same color without replacement. Okay, so this is more complex because 3 marbles of the same color. That means I don't care. So what are all of my choices? Why do you take out 1? Because it will, when you, all right, why do you take out 1? Because the question says find the probability of getting 3 red marbles. You can't just, the way that all of these questions work, no matter what, okay, all probability questions, it doesn't matter if you're choosing 3, 4, 5, or 6. You can only do things one at a time, always. Okay, you can only do things one at a time, always. So it's not like you have the 25 marbles, you stick your hand in and grab 3. Okay, you're doing things one at a time. Okay, C. Find the probability of getting 3 red marbles of the same color. So what are all of the choices? Well, I could get 3, let's see, I want to do it in the same order that I got. I could get 3 greens. That would be getting 3 marbles of the same color. Or I could get 3 reds. Or I could get 3 blues. All of these would satisfy the question of pulling out 3 marbles of the same color. In question A, they wanted me to pull out 3, only red. In B, they wanted me to pull out 3. A was only green. B, only red. Now in C, they're saying, I don't care which 3, just give me 3. So it kind of combines everything we did. I would have to find the probability of this, and find the probability of this, and find the probability of this. Now, because I don't care, and this or comes in, remember or probability, we're then going to add up all of those probabilities together. Now, it said without replacement, which means what? You're going to keep it. So 3 greens, right? Not 3 greens. You can get 3 marbles of greens. There are 5, so that would be 5 out of 25. 4 out of 24, 3 out of 23, because there are 5 green marbles, 25 total. Now, since it's without replacement, there are only 4 left and only 24 left, and you kind of keep doing that. Now, for the red marbles, you can have 12 out of 25, you can have 11 out of 24, then you would have 10 out of 23. Don't try to look at it as I did this, now I'm going to do this, where this number keeps dropping. These are 3 different, totally different scenarios. Now blue, there are 8, so it would be 8 out of 25 times 7 out of 24 times 6 out of 23. Okay, then you would find this answer, you would find this answer, and you would find this answer. So then that's going to be 60 out of 13,800 plus 1,320 out of 13,800 plus 336 out of 13,800. And then again, put it into your calculator. Now this is adding, so you be careful when you're doing this one. That's going to be 1,716, 13,800. And there you go for that. Okay, so it's a little bit more complex, but again, just try to see if you can break it down and look at all possibilities. And the last one, D, find the probability of pulling out 2 blue marbles and 1 green marble in any order with replacement, which means you're going to be putting it back. Okay, so in C, we didn't put it back. In D, now we're going to put it back. Now, it's saying that you want 2 blue marbles and 1 green marble. Well, I could get blue, blue, green. I could get blue, green, blue. I could get green, blue, blue. All of those show the different ways you can get 2 blue marbles and 1 green marble. Now they don't care, so again, this is an OR probability. Now this one is going to be replacing it. So when you pull out the marble, then you put the marble back. Okay? So now you would find each probability. Then add them up. So if you're going to do blue, blue, green, how many blues? I know there are 5 greens, right? And 8 blues. So this would be 8 out of 25 times 8 out of 25 times 5 out of 25. Because again, we're putting them back. 8 out of 25 times 5 out of 25 times 8 out of 25. Here's 5 out of 25 times 8 out of 25 times 8 out of 25. Now again, you multiply this out, and that's going to be 320 over 15,625. They're all going to be the same because you're multiplying the same numbers, just in different orders. But its overall probability will be different because each time we put it back. So now you could go ahead and add them up. So that's going to be 960 out of 15,625. Now remember, you can always put them into your calculator, divide the numbers, simplify the numbers, or write it as a decimal. Okay, now let's go over to a table. Okay, reading from a table now, very similar. So the table shows the percent of graduating seniors who are going to college broken down into subgroups by gender. If a student was picked at random, find the probability that they would be a female going to college. So a female and going to college. So you need to know, well, how many of them are female, and then how many of those females are going to college. And then you would multiply because you want both. Well, in the total group, there was a 0.54 of females, and then of that group, there was 0.84 that was going to college. Multiply those numbers, 0.4536, and most of the time, we write it as 2 decimal places. Okay, B. They would be male, not going to college. So again, very similar. Okay, very similar, but you have to be careful because now here you need to know the male, and that's right here at 0.46. Now it says not going to college. Probability of not college. So if you look at this, they didn't give you the probability of not going to college. They only gave you the probability of going to college. So you have to do 1 minus, okay, the 78. So 27% or 23% would not be going to college, 22%. So I'm going to be multiplying this not, but I'm going to be multiplying it by 0.22. And again, remember, I'm just dividing these by 100 when that's where I'm getting those numbers from. So 0.46 times 0.22, 0.1012, or 0.10. Okay. So C now, okay, probability of that they would be going to college, probability that they would be going to college. So now you have, okay, do they care if you're male and going to college? Do they care if you're female and going to college? No, they just care about all of them. So again, this is going to be one of those or, because we could have the male college or we can have the female college. Doesn't matter which one. Male, so the probability that you're male is going to be 0.46. And the probability that those male are going to college is going to be 0.78. Then the female, there's a 0.54 chance that it's going to be a female, and then that has a subgroup of 0.84. And now we just do our math. This is going to be 0.3588. This is going to be 0.4536. So 0.8124, 0.81. Okay, and then the last one, they would not be going to college. So again, now I know exactly who's going to college. 0.81 is going to college. So I don't have to do all the work, although you can do all of the work. But remember, all you can do is 1 minus, okay? 1 minus 0.81, or if you didn't simplify, 8124, and that's going to be 0.19, okay, or 19%. Okay, so there's that. So just make sure you take your time. Remember, you could always go back, hit pause. Okay, number 5. If a safety switch has a 1 in 10 chance of failing, so 1 in 10 chance that you're going to fail, how many switches would a company want to install in order to have a 1 in 1 million chance of them all failing at the same time? Show your reasoning. So let's say I had one switch hooked up with whatever and it went off. There's a 1 in 10 chance something would happen and it wouldn't go off. Well, what happens if I had 2 switches? If I had 2 switches, the first switch has a 1 in 10 chance. The second switch would also have a 1 in 10 chance. So that means that there would be a 1 in 100 chance that if I had 2 switches hooked up, that it would fail. Now the question wants to know here that how many switches would I need to have a 1 in 1 million chance? So basically 10 to the what power is going to give me 1 million. And do I have enough there? One more. And that would be 6. Okay, because 10 times 10 times 10 times 10 times 10 is a million. So it would be x is equal to 6. Okay, so you need 6 switches. And the last one, number 6. If the probability of winning a Carnival game, so the probability of winning is 2/5, and Max played it 5 times, write an expression that would calculate the probability he won the first 3 games and lost the last 2. Use the exponents to express your final answer. That just means don't use your calculator. So let's look at this. 1, 2, 3, 4, 5. Those are the 5 games. I want to win. I want to win. I want to win. I want to lose. I want to lose. Good morning. Nice of you to join us. So to win, 2/5. To win, 2/5. To win, 2/5. Now, if you don't win, then you lose. If you win 2 times out of 5, then you're going to lose 3 times out of 5. And there's how it gets set up. Now, again, you can simplify this. They don't want you putting it into your calculator. You could always simplify this as 2/5 to the 3rd power, 3/5 to the 2nd power, and kind of leave it at that if it answers the question the way they are answering it here. Okay. And they wanted exponents, so that's why I had to the 3rd and to the 2nd. All right. Now, what I need you guys to pay attention to and make sure that you're doing is you have a lot of stuff that you have to get done. Okay. So I'm just going to try to real quick pull that up so you can see. So one of the things that you're going to need to do is Delta Math. So get on Delta Math and answer those questions from Delta Math. Unit 10, there's a test. So make sure you try to get that done. Then you'll see right here, there are 2 reviews, review and Regents review. What's going to happen is we're not going to do a video tomorrow. We're not going to do a video the next day. We're just going to put up a video. Ms. Holden is going to do it for us, explaining the answers. Okay, and then you can watch those videos. And then on Friday, we're going to post another test because now we have finished Unit 12 in probability. We're going to try to hold an extra help session, so either myself and or Ms. Holden will do that. We will be in touch with you and let you know what needs to be done or when we're going to do those. But again, Unit 10 test, get that done. Unit 12, the next 2 days, today and tomorrow, get review and review Regents done, number 10 and number 11. Okay, so hope you guys enjoyed the video. And if you have any questions, leave some comments down there or